we define the limit of a function f of x as x approaches a as that number L that f of x approaches as x approaches a. The thing is though, there are times when the limit of a function as the independent variables approach a set number just does not exist. And the simplest reason that comes to mind is the one that we discussed in previous videos, the right hand limit not being equal to the left hand limit. And to see an example of this, we're going to look at the function mod x over x. And what we want to determine is the limit of this function as x approaches 0. Now, if we were to use the direct substitution method, we could just plug in the 0 and we would get that the function really and truly has no limit as x approaches 0. But why? Why exactly is that the case? Let's look at this from the graph. So before we do this, let's actually define mod x. So mod x is equal to x for x greater than or equal to 0, but it's equal to negative x for x less than 0. So now that we've defined this, we're going to look at it from the perspective, we're going to look at the limit of this function from the perspective of the right hand limit and left hand limit coming together to help us determine what the actual limit is. So we're going to look at the left hand limit first of all. What is the limit of mod x over x as x approaches 0 from the left? Now, if we're talking about approaching 0 from the left, that would mean that the values of x are less than 0. So if they're less than 0, what we would be looking at for the values of x would be these. So in this case, we are looking for the limit of negative x over x as x approaches 0. Now, we can easily tell that that cancels with that, leaving us with the task of finding the limit of negative 1 as x approaches 0. And we know that the limit of a constant is the constant, so that will be equal to negative 1. So now, we see that the limit of mod x over x as x approaches 0 from the left is equal to negative 1. Let's see what happens when we approach 0 from the right. Approaching x from the right means that the x values that we're looking at would be positive. So we would be finding the limit of x over x as x approaches 0. And since those two cancel, that would leave us with the task of finding the limit of 1 as x approaches 0. But as we said before, the limit of a constant is a constant, particularly the very same constant. So this would be equal to 1. So what that is implying is that the limit of mod x over x as x approaches 0 from the left is equal to negative 1, and the limit of mod x over x as x approaches 0 from the right is equal to 1. And I forgot my
so since the right hand limit and
the
left hand limit are not
if we were to look at this from the
then
graph,
we say that the limit of this function
this really
does not
is
exist.
the case, that the limit does not exist. So the plotted graph of mod x over x would look a bit like this. As this is an example of a piecewise function. Now, let's say that we're approaching 0 from the left. So we're here and we're getting closer and closer and closer to 0. What are their corresponding f of x values approaching? That's going to negative 1. That's going to negative 1. That's going to negative 1. And so on. So we can see that as x approaches 0 from the left, f of x is approaching negative 1. But if we're on the right here and we're approaching 0, and we go that point to that point to that point to that point, their corresponding f of x values are going to 1, 1, 1, 1, and so on. And so as x approaches 0 from the right, their corresponding f of x values are approaching 1. And so we now come to see how right-hand limit not being equal to the left-hand limit renders the function not having a limit in existence as x approaches a particular number. Now let's look on to another reason why the limit of a function may not exist. And to do this, I want you to look on this graph. This is the graph, the plotted graph of 1 over x plus 2. Now, let me just find that point of discontinuity at negative 2, right? And let me just indicate to myself that nothing should cross that line. And so the graph would look something like that. Now keep your eye on the graph and keep your eye on the function. And we're going to discuss a number of reasons why, both algebraically and graphically, we can come to the conclusion that the limit of this function does not exist as x particularly approaches negative 2. Now, looking at the function, if we were to use direct substitution, we would end up with 1 over 0. And we know that the limit of the function would not exist from that. And we cannot factorize, and so direct substitution is the only method, and that is implying that the limit of the function does not exist, and that is true, as we can see from the graph. Right here, we have the line x equal negative 2. And what happens here is that for the function 1 over x plus 2, as we choose values of x that are getting closer and closer to negative 2, their corresponding f of x values are just getting larger and larger as we approach negative 2 from the right. Why do we say that? Because the line x equals negative 2 is an asymptote to the curve right here. What do we mean by that? We mean that this curve here is getting closer and closer to negative 2, to the line x equals negative 2, but it never touches it. Why? It's like you have the line here, and you have the curve going up, going up, going up. And it will go up all the way to infinity, but it will never, ever touch negative 2. So since x approaching negative 2 from the right is getting has corresponding f of x values that are approaching infinity, they are going up and up and up and up and up with the curve. And the same thing happens when you approach negative 2 from the left. See, we're approaching negative 2, and we never reach negative 2. The graph of 1 over x plus 2 is actually approaching infinity. And so we get to appreciate that when we find the limit of a function and we end up having to divide by 0 as a result of direct substitution, as is the case here, quite likely what is the case is that as x approaches a, f of x is approaching infinity. All in all, what we have just shown is that for the function 1 over x plus 2, there is no set number such that as x approaches to 1 over x plus 2 approaches a single number that we can call L. There is no set number. And we see that that's the case because as x approaches negative 2 from the left, what happens? F of x just gets smaller and smaller and smaller and smaller. But as x approaches negative 2 from the right, f of x just gets larger and larger and larger. So in math, all we say is that as x approaches negative 2, f of x is what? Approaching infinity. So 1 over x plus 2 is just getting larger and larger and larger, or smaller and smaller and smaller as x approaches negative 2. And that implies to us that since there is no set number, in fact, since there is no set number that f of x approaches as x approaches negative 2, then the limit of the function does not exist.